Algebra, polynomials. A polynomial is an expression involving terms which are powers of a single variable. It can contain a constant term. Each power must be a non-negative whole number. So for example, we could have x squared plus 3x plus 2, or x cubed minus 4x, or 2x plus 3, or z to the power 6 minus 4z cubed. The order of the polynomial is the highest power of the variable in the expression. So for example, x squared plus 3x plus 2 has order 2 because the highest power is x squared. This is called a quadratic polynomial. X cubed minus 4x has order 3 because the highest power is cubed. It's called a cubic polynomial. 2x plus 3 has order 1, and it's called a linear polynomial. We will see that its graph is a straight line. Z to the power 6 minus 4z cubed has order 6. If we let y equal the polynomial, we can draw a graph. We see the graphs curve up and down across the page. The graph of y equals 2x plus 2 is a straight line, and that's where we get the name linear polynomial. Now, if the tangent at a point on the graph has gradient 0, the point is called a stationary point. On the graph opposite, we can see a local maximum point and a local minimum point. Now, if a point is a local maximum or minimum, it's called a turning point. A point along the curve where it changes turning in one direction to turning in the other direction is called an inflection point. An inflection point can be a stationary point. Now we can do arithmetic operations with polynomials. By that I mean we can add, subtract, multiply or divide polynomials in much the same way as we do with numbers. Now when combining polynomials we can either set it out in algebra form or in arithmetic form. So for example, we've got 5 sets of polynomials that are either added, subtracted, multiplied or divided together. If we set out an arithmetic problem, terms must be aligned in columns. In some ways these are easier than normal arithmetic problems as there's no carrying between the columns. So in the first example we have 3x squared plus 5x plus 6 and we're adding 2x minus 3. Now we can set that up in columns. There's a column x squared, x and numbers. So 2x minus 3 is below 5x plus 6. We also want to add 2x squared minus 6x plus 1. We write that again underneath, lined up in the correct columns. And then we just add the columns. Now since there's no carrying between columns, we can start at either end. So starting at the left, we have 3x squared plus 2x squared is 5x squared. 5x plus 2x minus 6x is plus x. And plus 6 minus 3 plus 1 is equal to plus 4. So our answer is 5x squared plus x plus 4. Now this could have been done just by removing the brackets and then adding like terms. So if we start with the original expression and remove the brackets, we end up with 3x squared plus 2x squared, which is 5x squared, 5x plus 2x minus 6x, which is plus x, and 6 minus 3 plus 1, which is plus 4. So we end up with 5x squared plus x plus 4, as we did by the other method. Now in question 2 we're doing subtraction. We set the columns one below each other. Now we start with 4x to the power 4 minus 5x squared plus 7x minus 6. There is no x cubed term in that expression, but we must leave a space for an x cubed column. And underneath we have 2x to the power 4 minus 3x cubed. There's no x squared term, so we leave a space, plus 5x minus 7. And now again, since we're not carrying between columns, we can just subtract column by column. So let's start at the front. 4x to the power 4 minus 2x to the power 4 is 2x to the power 4. Then we've got nothing. Take away minus 3x cubed. We'll take away minus is plus, so it's plus 3x cubed. Minus 5x squared take away nothing is minus 5x squared. 7x take away 5x is 2x. And minus 6 take away minus 7 is minus 6 plus 7, which is plus 1. So we have 2x to the power 4 plus 3x cubed minus 5x squared plus 2x plus 1. Again, this could be done by removing the brackets and adding like terms. So we start with the original polynomial, and when we remove the second bracket, that becomes minus 2x to the power 4 plus 3x cubed minus 5x plus 7. Now if we add the like terms, we've got 4 minus 2x to the power 4 plus 3x cubed minus 5x squared plus 7 minus 5 times x plus minus 6 plus 7. And that simplifies to 2x to the power 4 plus 3x cubed minus 5x squared plus 2x plus 1, exactly as we had before. Now in part 3 we have 3x squared plus 4x minus 6, and we're multiplying by 2x minus 7. And we can set that out as a long multiplication sum, making sure that we align the columns correctly. Now we can start by multiplying by 2x. So we've got 2x times minus 6 is minus 12x. 2x times 4x is 8x squared. And 2x times 3x squared is 6x cubed. Underneath we multiply by minus 7. Minus 7 times minus 6 is plus 42, and we put that in the number column. Minus 7 times 4x is minus 28x, and minus 7 times 3x squared is minus 21x squared. Now we add the columns, and since we're not carrying, we can start at either end. So starting at the left hand side, we've got 6x cubed plus, and then it's 8x squared minus 21x squared, which is minus 13x squared. Then minus 12x plus minus 28x, which is minus 40x. And finally plus 42. Now this could be done by expanding the brackets and adding like terms. So we multiply the first bracket with 2x minus 7. So that's 3x squared into 2x minus 7 plus 4x into 2x minus 7 minus 6 into 2x minus 7, and then we expand each of those brackets. Finally, we add up the like terms, and this gives us 6x cubed minus 13x squared minus 40x plus 42, just as we had before. Now in part 4, we do a long division sum. These are worth learning. You should know how to do long division algebra sums. They will come up over and over again in further questions. We divide x cubed plus 4x squared minus 3x minus 12 by x minus 2, and we set it out exactly like a long division sum. Now to start, we divide x into x cubed, and that goes x squared. We write x squared in the x squared column. Then we multiply x squared with x minus 2 at the front, and that gives us x cubed minus 2x squared, and we do a subtraction. X cubed minus x cubed leaves nothing. Plus 4x squared take away minus 2x squared leaves 6x squared, and we bring down the next term, minus 3x. Now that's exactly like we do in long division. We now repeat the process. We say x into 6x squared, and that goes plus 6x. We multiply 6x with x minus 2, and that gives 6x squared minus 12x. And we do a subtraction. 6x squared take away 6x squared leaves nothing. Minus 3x take away minus 12x, that's minus 3x plus 12x is 9x. We bring down the next term, minus 12, and then we divide x into 9x, and that goes plus 9 times. So we multiply by 9. 9 times x minus 2 is 9x minus 18, and we subtract minus 12, take away minus 18, that's minus 12 plus 18 gives plus 6. So our answer is x squared plus 6x plus 9, remainder 6. Let's look at example 5. We've got 4x cubed minus 8x squared plus 9x plus 7, which we're dividing by 2x plus 1, and we set it out again as a normal division sum. Now we start by dividing 2x into 4x cubed, and that goes 2x squared, which we write above in the x squared column. We now multiply 2x plus 1 by 2x squared, and this gives us 4x cubed plus 2x squared. We then subtract. Now, minus 8x squared take away 2x squared leaves minus 10x squared, and we bring down the next term, plus 9x. We now repeat the process. We divide minus 10x squared by 2x, and that gives us minus 5x. We then multiply the minus 5x with the 2x plus 1, and that gives us minus 10x squared and minus 5x. We then subtract. And 9x take away minus 5x is plus 14x. We then bring down the next number, which is plus 7, and we divide 14x by 2x. That goes plus 7. We multiply the 7 with the 2x plus 1, and that gives us plus 14x plus 7, and when we subtract we get 0. So we have as our answer 2x squared minus 5x plus 7, remainder 0. Now we could have solved this algebraically by assuming that our answer is going to be of the form ax squared plus bx plus c, remainder r, and then evaluating a, b, c and r. Now if we start with the original polynomial minus r and divide that by 2x plus 1, that should leave us with ax squared plus bx plus c. So, if we multiply both sides by 2x plus 1, the original polynomial minus r is equal to 2x plus 1 into ax squared plus bx plus c. Now, we can expand the right-hand side. And that will give us, in the end, 2ax cubed plus 2b plus ax squared plus 2c plus bx plus c is equal to the left-hand side, which is 4x cubed minus 8x squared plus 9x plus 7 minus r. And what we can do is we can equate the coefficients. So if we look at x cubed, we have 2a is equal to 4, in other words a is equal to 2. If we look at the x squared coefficients, we get 2b plus a is equal to minus 8. Now we know a is 2, so 2b plus 2 is equal to minus 8, 2b is minus 10, and so b is minus 5. If we look at the coefficient of x, we get 2c plus b is equal to 9, so 2c minus 5 is equal to 9. In other words, 2c is equal to 14, or c is equal to 7. And if we look at the constant term, we see 7 minus r equals c, and c is equal to 7, which means r is equal to 0. So a is 2, b is minus 5, c is equal to 7, and r equals 0. So our final solution is 2x squared minus 5x plus 7, remainder 0. Now the following is an exercise. Pause the video at this point and have a go at these questions yourself. When you're ready, restart the video and I'll go through the answers. Okay, well let's have a go. In the first one we've got 3 polynomials which we've got to add, so I have written them down one above the other with the columns aligned correctly. And then when you add them up, x cubed plus 2x cubed is 3x cubed, 6x squared plus 5x squared is 11x squared, minus 3x minus 4x minus 7x is minus 14x, and plus 2 minus 8 plus 5 is equal to minus 1. So our solution is 3x cubed plus 11x squared minus 14x minus 1. In part B, we've got exactly the same thing, three polynomials. We want to add them together, and so we write them down with the columns aligned correctly. Then we can add x squared plus minus 2x squared plus 4x squared, which is equal to 3x squared. We can add 5x plus 8x minus 11x, which is 2x, and minus 3 plus 8 minus 9 is minus 4. So our solution is 3x squared plus 2x minus 4. Now in part C we're subtracting two polynomials, and so we write them down one above the other with again the columns in their correct order. And then we've got 2x cubed take away minus 4x cubed, which is 2x cubed plus 4x cubed, and that gives us 6x cubed. We've then got minus 5x squared take away 3x squared, which is minus 8x squared. X take away minus 7x, which is x plus 7x, which is 8x. And in minus 11 take away minus 9, that's minus 11 plus 9, which is minus 2. And so our solution is 6x cubed minus 8x squared plus 8x minus 2. In part D, we're again subtracting two polynomials. So we write them down one beneath the other with again the terms in the correct column. And that gives us x cubed take away 4x cubed, which is minus 3x cubed. 11x squared take away 8x squared, which is plus 3x squared. We've got a gap for the x term in the top row, so it's nothing take away minus 2x, which is plus 2x. And finally minus 11 take away 9, which is minus 20. So our solution is minus 3x cubed plus 3x squared plus 2x minus 20. Now in part E we've got a long multiplication sum. We write the two polynomials one above the other, and then we multiply the top row by each of the terms in the second row. So multiplying by minus 7 we get minus 14x cubed plus 28x squared plus 21x minus 28, and multiplying by 3x, again putting them in the right columns, we get 6x to the power 4 minus 12x cubed minus 9x squared plus 12x. And if we add these two rows together, that gives us 9x to the power 4 minus 26x cubed plus 19x squared plus 33x minus 28. And that's our answer. In part F we do exactly the same thing. We write the polynomials one above the other. We multiply the top polynomial by each of the terms in the bottom polynomial. In this example I've started by multiplying by 2x squared, then multiplying by minus 3x, then multiplying by minus 5, and when we add the rows we get 6x to the power 4 minus 17x cubed minus 7x squared plus 26x plus 10. In part G we again have got two polynomials, so to multiply them we write them one above the other, keeping the terms in the correct columns. Now I've multiplied to start with by 2z squared, then I've multiplied by minus z, and finally multiplied by plus 5. Now we can add up the columns, and that gives us 4z to the power 4 minus 8z cubed plus 3z squared minus 10z minus 25, and that's our answer. Now in part H we've got a division sum. We set it out as a long division sum, and we start by dividing x cubed by x. Now that goes in x squared times. We multiply x squared with x minus 3, and that gives x cubed minus 3x squared. We subtract. Minus 5x squared take away minus 3x squared is minus 2x squared, and we bring down the next term, plus 3x. We see how many x's go into minus 2x squared, and that's minus 2x. We write that in the x column. We multiply minus 2x with x minus 3 to get minus 2x squared plus 6x. We subtract 3x take away 6x is minus 3x, and we bring down the next term, plus 9. We then divide x into minus 3x, that goes minus 3, and we multiply minus 3 with x minus 3 to get minus 3x plus 9, so when we subtract we get 0. So our answer is x squared minus 2x minus 3, and there's no remainder. In part I, again, we've got a long division sum. We write it out as a long division sum, and we start by dividing 2x cubed by x. And that gives us 2x squared, which we write on the top in the x squared column. Then we multiply 2x squared with x plus 2, and that gives us 2x cubed plus 4x squared. We subtract 3x squared minus 4x squared is minus 1x squared, and we bring down the next number, minus 6x. We then divide x into minus 1x squared, which is minus 1x. We multiply minus 1x with x plus 2, and that gives us minus 1x squared minus 2x. And when we subtract, we've got minus 6x take away minus 2x, which is minus 6x plus 2x, or minus 4x. We then bring down the minus 8, and we divide x into minus 4x. Now that gives us minus 4. We multiply minus 4 with x plus 2 to get minus 4x minus 8, and when we subtract we get 0. So our answer is 2x squared minus x minus 4, and no remainder. In part J, we set up the division as a long division sum, and we start by dividing x into 3x cubed. Now that gives us 3x squared, which we write on the top in the x squared column. Now 3x squared times x plus 3 is 3x cubed plus 9x squared. We subtract 5x squared take away 9x squared is minus 4x squared, and we bring down the next term, which is minus 11x. We then divide minus 4x squared by x, which gives us minus 4x, and multiply minus 4x with x plus 3. And that gives us minus 4x squared minus 12x. We then subtract. Minus 11x take away minus 12x is minus 11x plus 12x, which is plus 1x. We bring down the last term, and we say x into 1x, which is plus 1. We multiply 1 times x plus 3, and that gives us 1x plus 3, and when we subtract, we get left with 1. So our answer is 3x squared minus 4x plus 1, remainder 1. In part K, we set out the division as a long division sum, and we divide 2x into 4x cubed. Now that gives us 2x squared, so we multiply 2x squared with 2x plus 1, and that gives us 4x cubed plus 2x squared. We subtract 8x squared minus 2x squared is 6x squared, and we bring down the next term, minus 11x. We then divide 6x squared by 2x, and that gives us plus 3x, which we write on the top. 3x times 2x plus 1 is 6x squared plus 3x. We subtract minus 11x, take away 3x is minus 14x, and we bring down the next term. We divide minus 14x by 2x to get minus 7, and we multiply by minus 7. So that gives us minus 7 times 2x plus 1 is minus 14x minus 7. And when we subtract, we get 0. And so our answer is 2x squared plus 3x minus 7, and no remainder.